The following past question reads that the following equilibrium is set up in a mixture of concentrated nitric acid and sulfuric acid. So you're given an equation and you're asked which will correctly describe the behavior of each substance in the equilibrium mixture. So this is the equilibrium mixture where you have sulfuric acid and nitric acid, and you have to figure out which one is an acid and which one is a base. Now, according to Bronsted-Lowry acid-base theory, an acid is a proton donor or H+1 donor, or it produces an H+1 ion, and a base on the other hand is a proton or H+1 acceptor, so it gains H+1 ion. So I need to figure out what's happening in this reaction. So if you look at this reaction over here, and let's see what happens in the forward direction, what happens to nitric acid. Nitric acid gets converted to H2NO3 plus. So you can see the change that it's gaining H+1, and anything that's gaining H+1, that would be an acceptor or a base. So nitric acid, the first option, nitric acid is going to be a base, not an acid. On the other hand, let's look at sulfuric acid. Now sulfuric acid, as you can see, it changes from H2SO4 to HSO4 minus. So sulfuric acid on the other hand is losing an H+1, so it's acting as an acid. So sulfuric acid is acting as an acid, so these three would be correct. It's not a base, so let's cut that out. Let's cut out acid for HNO3. Now in the reverse direction, if you look at H2NO3, so you would notice that H2NO3 is getting converted into HNO3 back again. So it's losing its H+1, it's producing an H+1. So this is acting as an acid in the reverse direction. Similarly, if you look at HSO4 minus 1, in the reverse direction, it gets converted into H2SO4, so it's gaining an H+1. HSO4 minus gets converted into H2SO4, so it's gaining an H+1. So this is acting as a base in the reverse direction. So these are your conjugate acid and conjugate base. So H2NO3 is an acid. So it's an acid, whereas HSO4 minus 1 is acting as a base. So the correct option for this question is going to be option C for this question.